So one of the most important things that we have to be aware of and pay attention to when we're building these houses is the air sealing of the building. Today we're going to talk about the elements of the air sealing, which has to do how we close both the panels together so there's no air leaking into the building that's unintended, but also how we connect that down to the foundation. To begin with, we were building this building with the panels, which we've previously talked about, which are SIPS panels, structurally insulated panels, which have 2 layers of plywood with a foam core center. These panels are large, they're 4 feet in width, which allows us to have very few joints in the building. Once we have joined the panels together on site, there's a small channel left over that we come back and we spray expanding foam sealant into, which fills the void between these panels vertically. In addition to the foam sealant that we install inside the panel, on the exterior we come along and we'll prime the surface of this material, which is called OSB. The reason we prime it is we want to make sure that the tape that we use to join the 2 panels to make the airtight seal will be able to adhere to the panels very well. Oftentimes these panels have grime, dirt, dust on them, and by priming them we get a better bond. We're always willing to take an extra step in the air sealing because that is something that we cannot come back later and fix in the building if it doesn't work the first time during the construction process. So we'll do everything we can, including priming each of these joints and taping them to make sure we cut down as much unintended air moving through the building as possible, and in this case the panels. Another portion of the air sealing has to do with the connection of the panels to the foundation. What you see here is rigid insulation on the exterior of the foundation, which isolates the exterior cold air and earth from our foundation system. But this joint between the foundation and the panels is also critical. You can see here a black line, which is a caulk joint, helping to seal to make sure that no air goes in there. But in addition to that, if you look back here, we use this product, which is an adhesive back membrane, to join these 2 together and again create as much of an air barrier as possible. In this case, we also use this membrane as a way of shedding water off the building and protecting the wood from the exterior moisture of the ground and the air and rainfall. And on the interior, we have another layer which is continuous under the entire building and up to the panels. A layer of plastic has been installed, which we adhere to the inside face, much like this, but instead of just coming down and covering the foundation, it goes under the entire building, under the slab of the building, and everything contained within it to create an air barrier from the ground below. Because believe it or not, there's a significant amount of air that can be drawn into the building through gravel and the layers of insulation below the ground. So we have to provide a consistent, continuous air barrier under the building as well. That is not oftentimes included in most types of construction. Now the final place where we have to make sure that our air barrier is consistent and complete is in the ceiling layer. Because from the panels, when you go up to connect to the ceiling, creating a consistent barrier all the way around the building is important. In this case, we've used a truss roof for the structure of the building, which is an inexpensive way to create the roof structure. And then on the interior, we've installed a type of plywood that actually has the painted surface already applied in the factory, so we can tape the joints without the extra labor. Because when you look at the amount of energy that a house would lose through the air moving through the walls that's unintended, it's really significant. And when we're trying to make a high-performance building like this, we have to be very careful and cautious of every layer to ensure that that doesn't happen. In our case, the entire shell of the building, what will be allowable for us in terms of the amount of infiltration, is about a combined opening of about this large, not less than a square foot of combined area opening. Many houses usually have openings about this size when you do a test on them. But in our case, we need to have only an opening that's combined about this large. So every little crack and every joint and every seal must be as well installed as possible so we can keep that airflow down.